So in this video, we're going to talk about linear functions. So any kind of function, what you can do with it is create a table of values. So if you can't even recognize that this is a linear function, you can always make a table of values. These are just random values that we picked for x, and we're going to be plugging those into the equation. So for example, I could do y equals -2 times, I'm going to plug in this value, -2 for x. And then if I do -2 times 2, that gives me +4. And then +4 minus 2 equals +2. So if I do that for each value, I'm going to be plugging in each value. So next time I'm going to plug in -1 where I plugged in -2. And if I do that, I would get 0. When I plug in 0, I would get -2. When I plug in 1, I get -4. And then I plug in 2, I get -6. So you can use your calculator, or you can do it by mental math, either way, just to get the table of value. Now we're going to plot those points. So if I plot -2 and then +2, that's that point right there. -1, 0 is right there. 0, -2, 1, -4, and 2, -6. So you notice that all of these lie on a straight line, like that. So they all lie on a line. So if they lie on a line, you just connect the points just like I did. Okay, so that you can, remember, you can always do that with any equation. It doesn't have to be linear, but you can always make a table of values. However, this is pretty cumbersome. So I want to remind you about what you learned in Algebra 1. So remember that linear equations can be in the form y equals mx plus b. And this is very nice to graph because the m represents our slope and the b represents our y-intercept. So those 2 points make it very easy to graph if it's in that y equals mx plus b form. So if we look at that first graph there, that first equation, I have a -x. Remember, that's a -1 in front of there. So that's my slope. And this is my y-intercept. So we always plot the y-intercept first. I'm going to go on the y-axis. Here's my y-axis. I'm going to go up to 3 on the y-axis. 1, 2, 3. There's my y-intercept. And then I'm going to count my rise over 1. My slope is -1, and any whole number is over 1. So that means I got to count down 1 over 1. So from this point, from 3, I'm going to count down 1 over 1, down 1 over 1, and when I'm saying over, I mean to the right, down 1 to the right 1, and I can keep doing that, and then I'm just going to connect those to make a line. Okay, so one more example. We've got, this is 1/2 is my slope, so I'm going to have a rise over 1 of 1 over 2, and this is my y-intercept. So always start first with that y-intercept. So go to 2 on the y-axis, and now this is a +1/2, so that means I'm going to go up 1 over 2. Up 1 over 2. And then if I wanted to go backwards from my y-intercept, then I would go in the opposite direction. So I would go down 1 to the left 2. Down 1 to the left 2. And then connect your points. So why don't you pause the video right now and try number 14, the -1/4 x minus 1, and then you can check it when you're finished. Okay, so your graph should look like this. If it does not, see if you can figure out what you did incorrect. If it does, great, let's move on. All right, so function notation. You're very used to seeing lines with y equals something, and function notation, all that does is it replaces the y with f of x. So this means the same thing as y. Now the way we read that is f of x. So f of x is how we say that. And really, we do this so that we can name different functions. So I can name that very first equation that I graphed, I can name that f of x. And then the second graph, I can name that, let's say I wanted to name that g of x. So g of x would be the 1/2 x plus 2. And then this last one that you did on your own, we could call that h of x. So I can talk about the line h and the g line and the f line, and then you know exactly what I'm talking about. So that function notation allows me to be more specific. It also tells me what is the independent variable. The f of x, that just means x is the independent variable. That's where you're going to be plugging in numbers. So that's all that means. I don't want you to get confused by that. It means the same thing as what you learned in Algebra 1, and I want you to be used to both notations. So let's look at this problem here. So don't be intimidated by all the reading, okay? We're at the beginning of our 8-hour shift, and there's 42 units of furniture that we have to assemble. All right, so the number of units is they're using the letter N to represent that, is how many that still need to be assembled throughout your shift. All right, and they gave us an equation. Notice that they gave it to us in function notation. So this is N of t. And then they're saying t is a time in hours. Okay, so if we think about it, what's the independent variable? So what happens no matter what? That's always our time, right? So time is our independent variable, or rather t is the actual variable we're using for that. And then the dependent variable is the n, the number of units. So n is our dependent variable. So when we graph this, we are essentially graphing y equals negative 3x plus 42, except they used n and t, whereas what we're used to using is y and x. So if I use that, if I do that on this graph, please pay attention to the scale over here. Over here, the units are going by 5. But down here, the units are going by ones. Okay, so when we do our rise over run, we have to be careful with that. So I'm going to start at positive 42. I'll estimate that to be right here. And then I'm going to count down 3. So if I'm starting at 42, that's right here. If I count down 3, that would put me at 39. So I'm going to count down 3 and then over 1. And then if I go down 3 again, that'll put me down at 36. So down 3 over 1. And then let's do one more. If I go down 3 from there, that's 36 minus 3. That'll put me at 33. So that'll be about right there. So you can see my line is going to look like this. So that's how you graph something like that with different scales. Okay, and let's look at this question. It says, what is a reasonable domain and range of the model? So now we're not just talking about what are the x's, what are the y's. Okay, we're asking what makes sense for this problem. So remember, domain are the inputs, right? What inputs, what are the independent variables would make sense? Remember that independent variables is this time, t. So what kind of time makes sense? Obviously, I can't go backwards in time, so nothing negative would make sense. Also, if you go back to the beginning of the problem, it says you have an 8-hour shift. So anything beyond your 8-hour shift doesn't really make sense. So our domain, really the only values that make sense are going to be when t is between 0 and 8. So from 0 to 8 hours are the only values for the domain that make sense. And then for our y values, our range, remember those are the y values, those are the number of units. So how many units make sense? Well, remember, we're starting with 42 units, and that is going to go down from there. So I'm not going to have anything bigger than 42, and I'm obviously not going to have negative units. So anything between 0 and 42 makes sense for this problem. Now, does that mean that lines don't go on forever? No, they do. But when we're doing something in a in a word problem situation, we want to make sure that we're using the part of the line that makes sense for us. Okay, so in 26, it says how many units still need to be assembled after you've worked 5 hours. Well, how do we know what to do with that? 5 hours is time, right? So that means we're going to be plugging in 5 in for t. So I have n of 5. So this is just a name, right? That I don't do anything with that. So don't calculate anything here. That's just a label. What we are going to calculate is when we plug this into the actual equation part. Okay, so I'm going to be doing negative 3 times 5, that's negative 15. I'm going to add 42, so that's going to give me a total of 27 units. So after 5 hours, I still have 27 units that I have to assemble. Okay, so the next exercise that you see on your paper, we're going to do that in class. So just leave that blank, and we will do that when we do our warm-up.